Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve today are the ones that you're going to find on page number 229. The topic itself begins on page number 228, and the topic today is simply, what is a function? The original lecture and the original problems, the problems that you see on page number 229, appeared on the same page number in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original lecture, you will find it on day number 106. But basically today I'm going to repeat everything that we talked about on day 106. Basically what we're going to understand today, essentially what we want to understand today is, what is a function? Let us find out, shall we? What is a function? A function is a relationship. Is a relationship between two or more variables. It's a relationship between two or more variables. For example, y is equal to 2x is a function. This is a function because it shows a relationship between the variable x and y. It shows us how x and y are related. It tells us that the value of y is 2 times the value of x. That's the relationship. X and y are related in the sense that value of y is 2 times the value of x, or if you like, the value of x is half the value of y. It's a relationship. It's a function. A function is just a relationship between two or more variables. Here's another one. So is y is equal to x plus 3. This is also a function. Mathematicians call it function. The translation of the word function in English language, in the language of mathematics we call it function. In the English language we call it relationship. That's all it is. A relationship is what mathematicians call a function. This is another relationship between x and y. Here we are told that the value of y is 3 more than the value of x. There you go. That's how they are related. Value of y is 3 more than the value of x. That's another relationship. The question is, but as you can see, but obviously these two are two different relationships. This relationship and this relationship between the variable x and y are two different relationships, as we can clearly see there. We have to have, therefore, some way of distinguishing them. We have to have some way of distinguishing them. We cannot go around all day saying this relationship, not that one, that relationship, not this one, the first one, not the second one. They'll be annoying as hell. They'll be bloody nuisance. We have to have some way of distinguishing this relationship from this relationship. Well, how do we distinguish people? You know, we don't say this boy, not that boy over there, not that boy. Well, how do we do that in real life? Everybody has a name. That's how we distinguish people. Michael, not Paul. That's exactly what we do in mathematics. We give this relationship names. We have to have, I hope you can read my handwriting. We have to have some way, which is why I read everything, we have to have some way of distinguishing this relationship. I know the handwriting is atrocious. We have to have some way of distinguishing them. And how do we do them? By giving them name. We do so We do so by giving these relationships names. That's all. So here's our first relationship. Y is equal to 2 times x. Here's our first relationship. Here's our other relationship. Here's our second relationship. Y is equal to x plus 3. Let's give them name. What do you want to call first relationship? Well, let's call it F. Why F? Because that's just a tradition. That's just a convention. Because the word function begins with the letter F. So the first relationship typically it's not a rule. Nobody's going to come and arrest you in the middle of the night. If instead of F you call it alpha or beta or monkey or gamma or hippo or Michael, you can call it anything that you want. It's just a name. But typically, conventionally, we tend to name the first relationship in the discussion with the letter F. It's just a convention. It's just a tradition. That's all. We're going to call this F. What are you supposed to be going to call this one? Keep in mind, mathematicians are wild people. Mathematicians are a wild bunch. They're crazy people. They are wacky. They call the first one F and they call the next one G. Voila. So this one is called F of x. This one is called G of x. X tells you what the variable appears here. Instead of y equals to 2x, had we written down as y equals to 2a, instead of writing it down y equal to 2x, had we written down as y equals to 2a, the relationship would have had the relationship between variable a and y. In that case, we would have said f of a. Had this been a relationship between y and some letter p, 2p, we could have said f of p. P tells you what this variable is. We have a name for it. We'll come to that in a second. So here we have f of x and g of x. Here's another relationship. Here's another relationship. Here's another one. Y equals to 1 over x. Well, that's an entirely different relationship altogether. It's a third relationship. We have to give it a different name. We have f of x, we have g of x. Let's go on the y side, let's call it h of x. There you go. So the fact that one is called f of x, and the other one is called, this is how it's read. It is read as, this is read as f of x. This is read as g of x. That's how we read it. That's how it's read. This is called h of x. H of x. That's how we read it. That tells us that because they have 3 different names, that tells us that there must be 3 different distinct relationships. Let's continue then. I need the room, so we can start from the top. So here's our relationship, y equals to 2 times x. This variable that I just showed you, p and other variables that I showed you here, this variable is called independent variable. And this variable y is called dependent variable. Now if I misspell something, don't worry about it. As you know by now, if you've been watching my videos in the past, you know that I suck at spelling. I am no good at it. So if I misspell something, don't make a big fuss about it. Just understand the concept. Independent variable. Now why is x called independent variable and why is y called dependent variable? Because what the value of y is going to be is going to depend on what we put in here for x. If x happens to be 3, y is going to be 2 times 3, 6. If x happens to be 0, y is going to be 2 times 0, which is 0. If x happens to be 20, then y is going to be 2 times 20, which is going to be 40. So the value of y depends on what the x is. Hence, x is the independent one, and y is the dependent one. Now, had we written the same exact function in this form, x equals to 1 over 2y, is the same exact relationship, but in this format, y will assume the role of independent variable, and x will assume the role of dependent variable. You understand? So which one is the dependent variable and which one is the independent variable? Again, it's not something that's etched in stone. It is not something that is given to us. It doesn't fall from the sky. It all depends on how the relationship is expressed. So here, y is the dependent variable. The value of y depends on the value of x. In this format is the other way around. Let's continue then. We need the room again, as I keep pointing out. One more time, I'm going to read it very quickly before I erase it, before it's gone forever. So it says, obviously, the two relationships were two different relationships. Therefore, this symbol here means therefore. This symbol here, these three dots means therefore. Therefore, we have to have some way of distinguishing these two relationships. We have to have some way of distinguishing them. We do so by giving these relationship names. The first one is called f of x. The second one is called g of x. Then we introduce the third one, and we call that h of x. The third relationship was that. The third relationship is that value of y is the reciprocal of the value of x. That's what this says here. The third relationship tells me that the value of y is the reciprocal of the value of x. If x is 1, y is 1 over 1, which is 1. If x is 2, y is going to be half. If x is 10, y is going to be 1/10, and so on and so forth. It's a third relationship, it's a different relationship, you have to give it a different name. We called it h of x. In this format, this is called the dependent variable, this is called the independent variable. Let's go and continue then. The values that x can take are called domain of the function. Domain of the function. The values, the resulting values of y are called the range of the function. For example, in our f of x was y equals to 2x, I believe was the first one, which was our f of x. F of x here is defined for all values of x. In other words, here in this relationship, you can put in any value that you want for x, and you will have a value for y. Now that is always not the case. There are sometimes there are instances where for some value of x, you'll have trouble finding out the value of y. We'll come to that in a second. But in this case, in this function, x is permitted, and x is allowed to have any value it wants, any value that it pleases that you want. The f of x is defined for all values of x. Similarly, g of x, which was y equals to x plus 3, which was our g of x. Similarly, g of x is also defined for all values of x. But h of x, which was y equals to 1 over x, here the value of y does not exist when x equals to 0. Why is that? Let's find out, shall we? In this relationship, when y equals 1 over x, if x happens to be 0, what do you suppose is going to happen? Any number. We need the room, so let's continue on the top here. Any number divided by 0 is undefined, and this is how we write it. Any number which we represent with letter n divided by 0 is undefined. Now what does it mean when you say undefined? Well, it's infinity. It's called infinity because it is not a defined value. It's not a value that you can put your finger on. You cannot say, in other words, We do not sit there and say, well, I have one infinity here and there's another infinity there, that makes it 2 infinity. If I take away half an infinity, I'm left with 1.5 infinity. There is no such thing. It's not a defined value. It is undefined. It is an imaginary number. Therefore here, when x is equal to 0, this value becomes undefined. Therefore here, x is not, therefore here, x is not permitted to be 0. X is not permitted to be 0. So in this case, in the case of h of x, which is equal to 1 over x, here the domain is any number. Here the domain is, if somebody asks us what is the domain, you will say the domain here, when we talk about domain, we will say here the domain means x can be any value you want except 0. X is not allowed to be 0, as we said here. X is not allowed to be 0, because when x is 0, this whole thing becomes undefined. So the domain of this function is all values of all real values or all real numbers except x equals to 0. That's how we say it. The domain is all real numbers except 0. Are you with me so far? Now if you understand everything so far, that means we are ready to do the first problem that you see on the next page, which is 2.6.1. Let's take a look at 2.6.1. As always, we run out of room, so we have to keep erasing things. Now remember, any number divided by 0 is undefined. It's undefined. In other words, we can never have 0 in the bottom. We cannot have 0 in the denominator. Denominator is not allowed to be 0. Remember that. Denominator is not allowed to be 0. If somebody asks you why, you tell them because any number divided by 0 is undefined. We won't be able to figure out its value. It's not defined value. It cannot be, the denominator cannot be 0. Let's take a look at 2.6.1, shall we? (2.6.1) on page number 229. This is something that we did on day 106. Here, our f of x is 2 times x over x minus 0, x minus 6. Now, had our relationship is simply be 2 times x, there is no problem here. X can be any value it wants to be. X can even be 0, because 2 times 0 would be 0. No problem at all. So in this case, the domain would have been all real numbers, anything at all. But our problem is, in the bottom we have x minus 6. Ask yourself, when will bottom become 0? When will bottom become 0? Answer is bottom will become 0. Bottom will become 0 when x equals to 6. Because if x equals to 6, we substitute the value of 6 in here. It doesn't matter what top is. It doesn't matter. Top plays no role. Top is not the issue here. That's not a problem area. The problem is, as soon as you plug in 6 here for the x, what we end up is 12 over 0, and 12 over 0 is undefined. We can't have that. So what is the domain of this function? Domain of this function is all values of x except x equals to 6. Here the domain is all real numbers except when x is equal to 6. So here I need the room again as always. Therefore the domain for x. Now this part that I said domain for x, I just realized that that is redundant. That's what domain means. Domain means the permissible value of the independent variable. That's what domain means. Domain means permissible value. Domain means permissible values of the independent variable. Permissible values of the independent variable. Again, don't worry about the fact that the permissible is probably misspelled and the handwriting is atrocious, because I always read whatever I write. I always read it to you, so you have no right to complain that the handwriting is illegible, because I read it to you. Domain means permissible values of the independent variable, because domain actually means permissible value of the independent variable, and here the independent variable is x. Therefore this part is redundant. I don't have to say domain for x, because there is no such thing as a domain for y. This was redundant. Therefore the domain is all real numbers except x equals to 6. That's how we say it. Except x equals to 6. X cannot be 6, because the bottom will become 0 when x is equal to 6. Because the bottom will become 0 when x is 6. So the domain here is all values, all real numbers. X can be any number that it wants to be. X can be any value it wants to be except 6. It is not allowed to be 6, because if it becomes 6, all hell is going to break loose. Because if x is equal to 6, the bottom will become 0 and the whole thing will explode. It will become infinity. That's all. That's all there was. Tomorrow we'll do problem number 2.6.2, which may seem like a very simple and very straightforward problem, and 2.6.3 again may seem like a very straightforward problem, but there are some concepts behind it that I want to make sure that you understand, and I don't want to start them right now, because this will turn into a very long video. As it is long enough. I'll see you tomorrow, where we will understand the concept that lies behind the problem that you see on 2.6.2. Okay, bye now.